Hello, everyone. Thank you for coming to our presentation on programming workflow. Before we begin, this is only one out of 12 presentations in our series. You can see the list of presentations in the link we will send in the chat. If you have missed one of the seminars that you have wished you could have attended, don't worry. This seminar, along with all others, are being recorded and will be posted on our YouTube as soon as possible.
Okay, so this seminar is going to be about the programming workflow, and it's basically just going to teach you from start to finish how to write in op mode to make your robot do stuff. So this is mostly going to be based on Android Studio development, but there are a lot of parallels to the other programming environments. And we'll mainly just talk about linear op modes and iterative op modes or just op modes. Okay, so the workflow for programming is going to be program, test, repeat. And you really need to test your program really often because you can't just program the entire op mode in one go and expect it to work. You make one thing move, you make one change, and then you test it. Otherwise, it's going to be a headache. Okay, so for actual programs, you start by declaring all your variables, um, like your motor objects. You declare certain integer values, and then you initialize your objects by matching your variable to the actual hardware instance um, that you get from your config file. And then you can start your program. Okay, so in op mode, it stands for an operational mode. And it's basically just a program that your robot can run. And you have autonomous op modes, which are pre-programmed and sensor controlled. And you also have tele-op op modes, which are driver controlled op modes. And that's when you get to use your controller. Okay, a type of op mode is a linear op mode. And this is probably what you would be most familiar with if you know how to code. It basically just runs top to bottom. And here on the screen, there's some important methods you need to know. So run op mode, you go forwards a bit. It should like not that forwards, back, back, back. Oh, I thought I annotated. Okay, so run op mode runs exactly one time on init. So once you press the init button, it would run. And this is where you should put all of your like initializing. Wait for start happens one time when you press the start button. So init runs run op mode, and then start uh, is when it goes past wait for start. And you can use the is started method to check if your op mode is currently started. Um, you can do that just for some like uh, I don't know, to avoid errors or something. You don't typically use that very much. Um, is stop requested is another method that you can use to make sure your robot doesn't go crazy. Like at the stop of your op mode, you want to turn off all your motors if there is a stop requested. And that's basically when you press the square button on your driver station, it'll turn this method true. And that's when you want to turn all your motors off. And the rest are similar, but you don't typically need to use those very often. Okay, so from the top, you got your this first line here. It just gives your driver station information on where to put your op mode in the driver station. So your name is how it displays your op mode, and then the group sorts your op mode alphabetically in the driver station. So if your group was A, that means your this program, basic omni linear op mode, would be at the very top of your driver station list. Um, the next line, it says disabled. That means this program won't actually show up in your driver station. So that's just when you have code that you don't want to use during computation. Um, the next line is your class declaration. Um, yeah. And then you want to declare all your variables below. Okay. After all of your variables are declared, you want to use your run op mode method, and that's the one that runs after init. And this is when you initialize all those variables. So like left front drive, that's your motor object, and then you use the hardware map to match the physical instance of your motor to that variable, to the object. And where it says device name, make sure that string, the green string, that has to match the name that you give the hardware in the config file. And we'll talk about that later. So after you initialize all those variables, you can set things like set the direction to reverse certain motors if they're running the wrong way. And then at the bottom, telemetry, that's just going to tell your driver station that you are currently initialized. And telemetry is really useful to get information out of your programs. So it's not just super abstract and you can actually see what's going on inside. And make sure every time you use telemetry, you have to use this first line to add your information, and then the second line to actually display that information on your driver station. Okay, so this is your config file. In where it says port 0, in that drop-down menu, you would select the type of hardware that you're configuring. And then in the field below that, you would add a name and make sure that name matches those green strings there. Because if they're one character off or if there's a capital in there, it won't know which variable to match to which hardware instance. And you just have to do that for all your motors, all your sensors. Your camera should do it automatically, but yeah, all your hardware needs to be configured so your program knows what is what. Okay, so after all of that initialization, you can have this line, and this is still within the run op mode method. But if you put this line, all the code below it won't run until you actually press the triangle on the driver station and you start the program. So it's basically just a wait. It waits until the button is pressed. And this is how you have code repeat in a linear op mode. You do while the op mode is active, and then everything within the curly brackets will run after you press the triangle and before you press the square. Okay, so that was a linear op mode, and now we'll talk about iterative op modes or just op modes. Some people call them just op modes. And it's basically just a looping op mode. So you just have a bunch of different methods that run in loops. So your init, this method will only run one time when you press init. It's similar to run op mode, but your init loop is what runs multiple times. It runs in a loop. And it'll run until you press the triangle on the driver station to start the program. Start, it's like init, it runs once you press the triangle, once you press start. And then loop is your start loop. It's the loop that you want to put all the code in. And stop will run once, and that's when you want to turn all your motors off. So generally, you want to put your initialization in the init method. So you would have init and then curly brackets and all your variables being initialized in the init method. Okay. And I'll just go from the top here. So you have your information for the driver station. That's just like before, it's your uh like the name of the op mode and where to put it in your driver station. This program is disabled, so it won't appear in the driver station. So make sure you get rid of that line if you want it to appear. Um, the class is called basic op mode iterative, and it extends op mode. One thing I didn't mention before, if you want your op mode to be an op mode, iterative op mode versus a linear op mode, you need to extend a different class. And for iterative op modes, you need to extend op mode. And for linear op modes, you need to extend linear op mode. So that'll just give you access to all the different methods. Here we initialize a runtime variable and also one motor. And then in the init method, we initialize that motor and we assign it to the hardware that we called left drive in the config file. Then we reverse that motor so it'll run the opposite way. And in the init loop, there's no code, but you can put stuff in there, like maybe some camera stuff, but for the most part, you won't need that starting out. In the start method, we reset the runtime. So basically the program's clock is just reset to 0 once you press the triangle. And then in the main loop, you can do all your cool robot stuff. So, okay. So some useful functions when you're programming is going to be your telemetry.add data. That's a really, really useful way to test all of your programs. If you don't telemetry certain variables, it's going to be really, really hard to figure out what's going wrong with your robot when something does go wrong. And remember to update your telemetry at the end of your loop or after you add data to your telemetry. Otherwise, it won't appear. And yeah. So another thing you're going to use a lot is motor.setPower. And you would replace your motor there in italics with the variable name for your motor. So like left drive dot set power. And then motors can have a power of -1 to 1. -1 runs it backwards, 1 runs it forwards at full speed. And the same thing for servos, except set position. And then the numbers stand for like their full ranges of motion. So -1 would be all the way in a certain direction, and then +1 would be all the way in the other direction. Unless your servo is in continuous mode, because some servos run continuously and they'll just act like a motor. Okay, so one of the best resources for an FTC team starting out is Game Manual Zero, and it has pretty much everything you would need for starting out programming. It also has build stuff and outreach stuff, so I would definitely recommend checking out that website and looking at all the example stuff they have. Okay. So if you have any questions about this seminar, you can contact us with our email and we'll try to reach out as soon as possible.